Hey folks, welcome back to Chapter 1. We are going to talk about something called uncertainties in this lesson. Uncertainties are something that happen with all measurements in real life. Sounds like it might be a bad thing or you're doing the measuring wrong, but it's not. It just is. Uncertainties is a discussion about how when we take measurements, we can never be truly sure of exactly what the measurement is. We can be quite sure of the number we write down, but never exactly sure. And sometimes due to circumstances, we might be even more uncertain than in other instances. And I'll show you what that looks like in a moment. So let's consider this measurement. Don't write things down. Don't copy the notes when you see these things that look like rulers. But if you were going to take a best guess as to what that measurement is, you might write down something like 18.6. Now, what you're telling people when you write down a number of 18.6 is that the last digit, that 6, could actually vary by 1. So you're telling people the value, your measurement, is somewhere between 18.5 and 18.7. Our best guess is 18.6, but we're a little bit uncertain. Now, take that measurement, which we said was 18.6, somewhere between 18.5 and 18.7. What if you ran into this scenario? So what if you were measuring something like this? I can imagine my cat. If I took her to the vet and I put her on the scale, she's not going to sit still. She'd be trying to shred somebody's face off. And the scale's going to bounce around a whole bunch. So what do we do there? Or maybe you have just a really crummy measuring device and you put the cat on the scale and it looks like that. There's definitely some gray zone, right? We have some uncertainty there. We are not going to be as sure about our value or measurement in either of those situations. So what we have to do is not just pick a random number and say that's the best guess, because remember, if you pick 18.6, you're telling people that you only saw variation, or you only think there's variation between 18.5 and 18.7. But it turns out, if you go through these measurements, and again, don't worry about trying to figure it out, but the high side is 19.0 right there, and the low side is 18.2. So if we think about those as like goalposts, maybe you're a football fan, if we think about those as goalposts and we say, well, what's the middle? What would the middle of 18.2 and 19.0 be? Then the number is 18.6. But we have to be honest with people and tell them that we saw all of this variation. So here's what we do. We write down a number like that. So we write down 18.6, and then we put a little plus minus, and we show people what that gray zone is. So 18.6 plus or minus 0.4 is an honest measurement by a physicist that says, I think the value is 18.6, but the gray zone's a bit bigger, just because of circumstances. The value is somewhere between 18.2 and 19.0. And that's okay to have uncertainty. It doesn't mean you did a bad measurement or a poor measurement or it's wrong. You're just saying, hey, the measuring device I had or the thing I was measuring, I couldn't be quite as certain as I wanted to be. So some terminology that you don't need to memorize for the test, but you do need to know when we're chatting about this uncertainty business. The value is the best guess that you've made. So the value of the measurement is 18.6. And then there's multiple types of uncertainty. The first one is absolute uncertainty, which is the number that comes after the plus or minus sign. And that tells you your gray zone. That allows you to really quickly look and go, okay, it's 18.6, then the low side minus 0.4 would be 18.2, and the high side would be 19.0. Absolute uncertainty is what we always show on final answers. So I'm going to scribble that in there. Anytime we write down the final answer, we have to show people what that gray zone is by putting a value, plus or minus, and then an absolute uncertainty. Now, an absolute uncertainty on its own doesn't really tell you how big the uncertainty is compared to the value. So a really important calculation for us is something called relative uncertainty. How big is the absolute uncertainty relative to the value? So you can see that's all we've done here is we've taken the absolute uncertainty, and we've divided by the value sitting in front of it. And we get this number, 0.0215. That's going to be a calculation that's very useful when we run some math, when we crunch numbers with uncertainty. And then if you or I were chatting about some measurements, if we were doing a lab and we wanted to have a conversation, we probably wouldn't say, oh, my relative uncertainty is 0.0215, because that's kind of weird. We'd probably just convert into a percent uncertainty, multiply by 100. And you might say something to another lab group or to myself and say, hey, Mr. Heinrich, our percent uncertainty was 2.15%. We were only a little over 2% uncertain about the measurement, which is great. That's very low. I'd say, hey, that's a quality measurement. So that's the types of uncertainty. These two are the ones that we end up using more often. Absolute uncertainty for all final answers, and then relative uncertainty when we get into some calculations. Percent uncertainty if we're just chatting about the numbers with a classmate. Now, before we get into some rules for how to perform math operations with uncertainty, I want to show you how we round all final answers when you do have some uncertainty attached. So here are the two steps, and this will make more sense when I actually show you what's happening. Step number 1, you start by showing your uncertainty with only one sig fig. So going back to last lesson, we still have to remember how to correctly count sig figs. We only show one sig fig of uncertainty, always, always, always. And then once we get the uncertainty rounded to one sig fig, we then go back to the value and we make it have matching decimal places on the uncertainty. So the value can be any number of sig figs. It simply needs to match decimal places on the uncertainty. So the uncertainty actually sort of starts the game and sets the tone for what the rest of the answer is going to look like. So let me show you what that looks like in practice. Let's say we've got a value there in blue and an uncertainty there in green. We want to show that as a final answer. Step number 1 is I have to show that uncertainty with only one sig fig. That basically means one non-zero digit. So my cutoff would be right there. And that means my uncertainty for this question would be plus or minus 0.004. The 3 is going to round the 4 just as a 4. So I got my one sig fig, there's step number 1. And now we have to match decimal places on the value. So now I look at my value and I say, well, my uncertainty had 3 decimal places. That means my value can only have 3 decimal places. I don't care about sig figs on the value. I only care about matching decimal places. So there's my cutoff after 3 decimal places. No rounding to worry about here. The 8 is going to stay as an 8. So my value would be 0.028. There's step number 2. So one sig fig uncertainty, and then make matching decimal places on the value. Let's try another one. You'll start to get a hang of this pretty quick, I think. So second example, we start the same way, always one sig fig of uncertainty, which means the cutoff is right there. And this time we do have to round. The 8's going to round the 2 up. So that becomes plus or minus 0.03. And now I look at that and I say, hey, that's 2 decimal places. So my value can only have 2 decimal places, which puts the cutoff right there. The 7 will round the 8 up, and we end up with 0.19. That would be your final answer. Example 3, one sig fig of uncertainty. We always start there. That means our cutoff is right there, one non-zero digit. You have to be a little bit careful on this one because it's quite common for students to look and go, oh good, the 7 rounds the 9 up to a 10, I caught that. And they'll put 0.10, they'll put the 10 in. But you actually can't do that because that's 2 sig figs right there. So you actually have to lop the 0 off. There's one sig fig. Now we match decimal places. This is only 1 decimal place, so my value is only going to be 1 decimal place. That becomes 13.1. One sig fig, matching decimal places. Looks great. And let's try one last one. One last example. 1729 plus or minus 438. 1 sig fig of uncertainty, always, 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 means the cutoff is right there. And that means the 3 is going to keep the 4 as is. We are plus or minus 4. And now I would look at that and say, well, that's kind of cool. There are no decimal places on my uncertainty. So that means there can't be any decimal places on the value. So the 17.29, we're not allowed to show any decimal places. So the cutoff is right there. 17.2, that stays just as 17. So that's the drill for rounding answers with uncertainty, and that is always the drill, regardless of what the rules are for how we approach the question with the math. Any final answer needs to round, just like that. Now, let's look at what the math rules are. So when we're doing math with uncertainties, there are 2 different rules we have to follow. Just like when we were dealing with sort of sig figs, there is a separate rule for adding and subtracting, and then a separate rule for multiplying and dividing. So for adding and subtracting, here's what it looks like. You get to add the absolute uncertainties, which is what you're going to see in the question. You'll like this one. This one's quite easy. I'll show you what it looks like in practice in just a moment. And then we round the answer, doing that drill that we just practiced 4 or 5 times there. 1 sig fig uncertainty, matching decimal places. So let me show you what that looks like. Let's try adding those two. 2.3 plus or minus 0.2, 3.4 plus or minus 0.3. The first thing I would always do is actually just tackle adding the values. So ignore the uncertainty for the moment. What do you get when you add the 2 values? Well, you get 5.7. And then this rule says if you're adding or subtracting the numbers here, you simply grab your absolute uncertainties and you add them together. Nice and easy. So that comes out at 0.5. Now let's look at rounding. You're only allowed 1 sig fig of uncertainty. That one's done. And then you have to have matching decimal places on the value. So 1 decimal place over here, the 5.7 can only be 1 decimal place. Hey, sweet. That is already rounded. So that one, done. Let's try this one. First thing I would do is ignore the uncertainty. Just add those values together. So you punch those in your calculator. You're going to get 1.048. And since we were adding here, the rule is take your absolute uncertainties and simply add them together. 0.016. Now this one is going to require a little bit of rounding. We have to show only 1 sig fig of uncertainty. So that rounds to 0.02. And now we look at the value and we say, wow, we can't have 3 decimal places. That doesn't match up. We're only allowed to have 2 decimal places, which makes the cut right there. The 8's going to round the 4 up to a 1.05. So there's your final answer for that one. And I've got one more here. What about this one? So we're subtracting. First things first, grab your calculator, subtract those 2 values. You get 2.89. And now the question is, what do we do with these uncertainties? Is it 0.03 plus 0.03, or is it 0.03 minus 0.03, which would be 0? And I want you to look back at the rule. The rule said always add the uncertainties. Even though we subtracted the values, we still have to add the uncertainties together. So add 0.03 and 0.03, you get 0.06. And this one is rounded for us already. 1 sig fig of uncertainty, looks good. Matching decimal places on the value and the uncertainty, done. So that one looks fantastic. Now, let's look at multiplying and dividing. This one's a bit different. We now add relative uncertainties. And then we do the cleanup, the rounding of the answer. So first thing we want to do in this case is, and maybe I'll do this one with you. This one's a little bit trickier, the multiplying and dividing. Let's take 4.7 times 5.3. Just get an answer. 24.91. Plus or minus. Now we have to add relative uncertainties. And remember, to get a relative uncertainty, we take the absolute uncertainty and we divide by the value. So we take 0.2 divided by 4.7. and we add to it 0.3 divided by 5.3. Now, when you add two relative uncertainties together, your calculator is going to spit out a relative uncertainty. And we need to show final answers with absolute uncertainties. So there's one more step left to figure out what that uncertainty is. We have to change a relative uncertainty back into an absolute. And in order to do that, you're going to add these relative uncertainties in your calculator, and then we have to multiply by the 24.91. You have to multiply by your answer. So be a little bit careful in your calculator. You actually want to type it in just like I've written it down. So open a bracket, 0.2 divided by 4.7 plus 0.3 divided by 5.3. Then close your bracket, because BEDMAS, we want that addition to happen before we go and multiply by 24.91. So type it in just like I've written it there. Hit enter. There's your uncertainty, 2.47. So that's 24.91 plus or minus 2.47. Now we can do our cleanup. We're only allowed to show one sig fig of uncertainty. So be a little bit careful when you round this number. That's the cutoff. When you're trying to round the 2, you only look one digit over. The 4 keeps the 2 as a 2. You don't play a double rounding game where you say 7 rounds the 4 up to a 5, and then the 5 rounds the 2 up to a 3. You never double round like that. You simply look one door over, look on the right-hand side of my dotted line. 4 is going to keep the 2 as a 2. And then we match decimal places, which means 24.91 can't have any decimal places. That's going to round up to 25. There's your final answer. So let's try one more together, and then I'm going to get you to try some practice. So let's try this one. Shows up the odd time in the course. What if we take a number like 4.2 with some uncertainty, like 0.2, and we square it? Sometimes people get lazy. They think they can just square 4.2 and they can square 0.2. But it turns out it's not that easy, because if you think about what this is actually wanting us to do, it's wanting us to take 4.2 plus or minus 0.2 and multiply it by itself. Which means this is going to be a question just like the last one that we did, where we're going to grab our calculator and figure out what's 4.2 times 4.2. That's 17.64. Now we have to add relative uncertainties. So that's 0.2 divided by 4.2 plus. We're going to do another 0.2 divided by 4.2. And then we have to change that relative uncertainty back into an absolute uncertainty by multiplying by that original answer of 17.64. So we grab the calculator, we type it in just like it looks there. 0.2 over 4.2 plus 0.2 over 4.2, close the bracket. So make sure that's in brackets, and then multiply by 17.64. There's our uncertainty, 1.68. So that's 17.64 plus or minus 1.68. One sig fig of uncertainty is all we're ever allowed to show in a final answer. So 1.68 rounds up to become 2. And now we match decimal places, 17.64. The 6 is going to round the 7 up. 7 Up, everybody's favorite soda. We end up with a final answer of 18 plus or minus 2. So I'm going to pull up worksheet 3 and show you a couple of questions on there that you can try out for practice. So here's the practice sheet that goes with this lesson, worksheet 3. It's in the All Resources folder on the website. Here's the questions I want you to skip over for now, just because we haven't covered them, and we'll do this at another time. I'll get you to skip, or we'll make optional 2D, and then on question number 4, we're also going to make D optional. And I want you to actually stop question 4 when you get down to, what should we say? Let's say if you just get to k. That's far enough. I do want to point out that when you've got a question like h, where you're multiplying and dividing all at once, the rules for multiplying and dividing were the same. So make sure for a question like h, you're doing it all in one step. So what I mean by that is we would want to get our value here. So ignoring uncertainty, 4.3 times 5.5. Now go right into the division as well. Divide by 6.2. You'd get 3.8145. Plus or minus. Now we're going to have three relative uncertainties that we add together. So it would be a 0.1 over 4.3 plus 0.2 over 5.5. And you can do the division in there too. It's the same rule. Plus 0.1 over 6.2. Close the bracket. And then don't forget we need to go and multiply by that original answer. 3.8145. And I'll let you finish that off. But just to show you, if you're multiplying and dividing in the same question, or like f, where you're multiplying three numbers together, then just do it all in one shot. You'll simply have three little fractions or relative uncertainties that you need to add together in there. So give that a go. Check your answers on the answer sheet or online, and let me know if you have any questions or you want to go over this. Have fun practicing uncertainties.